Hey guys, what's up? Mr. Mathematician is back, and today I have an awesome video about circles. This is going to be a series, so stay tuned and be healthy as coronavirus pandemic is spreading all around. So over here, first I have 3 points: point A, point B, and point C. So in this case, we need to first make a circle that passes through all the 3 points, and we need to prove that only one circle can pass through all 3 of them. So I have a scale over here, and I'll join point A and point B first. So here I draw a line to join point A and point B. I'll do the same for point B and point C. Now what we need to do is, we need to bisect AB and BC. That means we need to create a line that is perpendicular to AB and BC. Okay, now to bisect any line, what you need is a compass. First we'll bisect line AB. So our radius should be more than half. That means more than half of the length of line segment AB. So here I have taken. Now we'll make 2 arcs, one on the right side of the line and another on the left side, with B as the center. We'll do the same, but now we'll take A as the center and we'll cut the previously made arcs at 2 different points. As you can see, there's one point where both the arcs have intersect, and we'll join those points together to form a perpendicular line that is a bisector of line AB. We'll do the same with BC first, line segment BC, and then we'll join them. So we'll take the radius as more than half of the length of line segment BC. Now we'll draw 2 arcs, one above the line and another below the line. Now we'll take C as the center and we'll cut the previously drawn arc. Now with the help of a scale, we'll join the points where the arcs have intersect. First we'll join the points and draw the perpendicular or the bisector of line segment BC. As you can see, now after doing this, we'll do the same for line segment AB, and the point where these bisector will intersect would be our center. So the point where these bisectors will intersect, as you can see, this point, as I show you. First we'll name both the bisectors. We'll name bisector that bisects AB as P and Q, and the bisector that bisects BC as R and S. Now the point that I show you, that is the point where the PQ and RS intersects, is our center. That would be our center, and we'll draw a circle with the center and we'll name it as O. Now to draw the circle that passes through all the 3 points, we'll take our compass, and the radius should be OC, OB or OA. All of them would always be equal because that is our radius, and the center is at equal distance from all the 3 points. So here I took the radius as OA, and now I'm drawing a circle. Now as you can see, the circle passes through all the 3 points. And now what we need to do is, now we need to prove that there is only one circle that passes through all the 3 points. That is point A, point B and point C. Now to do that, first of all, we know that we'll take our pen and we need to write this. So we all know that PQ, that means we have first joined AB and PQ is perpendicular to it as it is a bisector. So we'll write AB is perpendicular to PQ. If anyone doesn't know, the reverse T is the sign for perpendicular as shown. We'll do the same for RS and BC. So BC, line segment BC is perpendicular to RS, line segment RS. Now that means PQ and RS, the point where PQ and RS intersects, that is point O, would be our center. And there is always only and only one point where two lines can intersect. So now we'll write that our center is O. So therefore O is our center, is the center. Now we need to prove that there is only one circle that can pass through all the 3 points. So as O is the center and only one circle can pass through all these points. To prove this, first of all, we can take any imaginary center and the radius should be equal, right? So we can take any imaginary center. Let's say the center to be Z, doesn't matter, but we need to create a circle with the center and all the 3 points passing through it. First of all, for that, we all know that OA is equal to OB, which is equal to OC, because that is our radius over here. So we can also write it as OA equals to OB equals to OC equals to R, small r, that is our radius. When we have a radius equal to, when the distance between the center and all the 3 points is equal, that means it's the radius, then only we can draw a circle that passes through all the 3 points. Now we can try to draw another circle that passes through all the 3 points A, B, C. But for that we'll take an imaginary center, that is Z. Now what we need to do is, Z should be the point where lines PQ and RS intersect. And as we know that there is only one line, there is only one point where two lines can intersect. And over here it is point O. So over here what will happen is, our O would be our Z. That means our center would remain same if we try to create another circle. And that means what will happen is, our radius will also be the same and we will draw a congruent circle. So if we try to, therefore there are no possibilities. There is only one and only circle that can pass through 3 non-collinear points. Only one. And to prove that, you need to write down that a line intersects with another line at only one point, and that point would be our center. So we cannot get another center, and therefore we cannot draw another circle with this that passes through all the 3 points. So there is only one possible circle that passes through all 3 points. That's it for the video, guys. Sorry for the delay, but there were some technical issues. Thanks for watching.